we have this question right here. It's asking show that S is a subspace of R2. So in this case, what you have to do is um, to any element that to become a subspace of Rn, it should have to fulfill three things. First, it should be in a zero. It should have a zero element, and the second thing is it should be closed under addition. And the third thing is it should be closed under scalar multiplication. So these are the three things we had to look at before we determine whether it is a subspace of R2 or not. So first check whether it is a zero element. So in order to find whether it is a zero element, I have to simply substitute 0 for y and x and see whether I am getting 0, 0. So if I substitute, it's going to be 0, y is equal to 2 times 0, so which is going to be 0, 0. Therefore 0, 0 is 0, 0 belongs to S, which means 0 element exists, so it passed the first part. Now second part, I have to see whether it is a closed under addition. So in order to do that, I have to simply take let's say u vector is, let's say u and v vectors are in S, and if I take u vector as xy, and let's take, so I have to take another vector to prove that this is closed under addition. So let's say I take v, and let's say this is AB. So if I take this one, then what I have to do is I have to simply add them together. Before I add them, I have to consider this equation. So we have this this equation right here. It's y is equal to 2x. So if this is true, then the new one I took, it means what does this really mean is the first like this, the second value what I will be taking is 2 times of the first value. So it means if this is y it's 2, it's equal to 2x, then it should be same under this condition. If it's b, then it should be equal to 2a. So b should be equal to 2a. Then I have to add this to it and see if the same thing true for the whatever the value we are adding and getting. So it's going to be x plus a, y plus b. So if it's closed under addition, so then it should be true here too. So for example, this value should be equal to double time of this value. So if it should be y plus b should be equal to 2 times x plus a. Let's see if this is true. So first of all, I form an equation. Let's say okay, y plus b. I form an equation y plus b, and if I add y plus b, I derive this value, right? 2x plus 2a. So I substitute y value for 2x, b 2a for b. Then I can take 2 common, so it's mean x plus a. But so if you see, this is equal to here. If I take y plus b, according to this formula, y is equal to x. So any value that should be double time of this one. So if I take this one, it should be equal to 2 times x plus a. We prove that it's true. Therefore, this is this one, u plus v belongs to S. Therefore, this is closed under addition. And the third one, we have to prove this is closed under scalar multiplication. Here is the same thing. First of all, we have to say u belongs to S. Then we have this equation y is equal to 2x. So I have to take a scalar number. Let's say I am taking alpha. Alpha is a scalar number, and we also have xy belongs to R. Then I take this y is equal to x. First of all, let's multiply this alpha. So let's say this is the scalar number I'm taking. So alpha times u. So this is equal to alpha u contains x and y. So if it multiply u, then we have to multiply x and y by alpha. So x alpha y. So we have to prove this is true. So if y is equal to x, alpha y should be equal to alpha 2 alpha x. So let's first I'm multiplying this one by alpha. So alpha y and alpha 2x. So if I'm multiplying this equation, so by alpha, and it should become alpha y is equal to 2 alpha x. So if I take this one here, it becomes same, like alpha y is equal to 2 alpha x. Therefore we can say alpha u belongs to S. Therefore this is this closed under scalar multiplication. Therefore this is therefore we can say this is S is a subspace of R2. So this is how we prove this question. I hope you guys like this video. See you next time.